Hello everybody and welcome to today's lesson on completing the square. We are still in our unit 3 on quadratic functions, and completing the square is one of the three methods on how to solve a quadratic equation. The other ones being factoring, which we already talked about, and the quadratic formula, which we will talk about in our next class. Today's objective is we will find solutions to quadratic equations algebraically by completing the square. So let's get going. If we look at this equation up here, x squared is equal to 16. How can we solve that? Fairly easily. We just take the square root of both sides of the equation. The square root of x squared is x, right? Squaring and square root are inverse operations, so they cancel each other out. And on the right, we have plus and minus, positive and negative 4 as our answers. We have actually two answers. Think about it. If we take 4 and square it, we get 16. But if we get negative 4 and square it, we also get 16 because we're multiplying two negative numbers by each other. So when we take the square root, remember that we always have two answers. If we look at the example on the right, we have the quantity of x minus 2 squared is equal to 5. Since the entire left side of the equation is squared, we can again use our square root to solve that equation. And on the left, we're now going to have x minus 2. On the right, we are again going to have positive and negative. But since the square root of 5 we can't simplify, we're just going to keep it like that. Now we add 2 to both sides of the equation to bring over the 2, and we get x all by itself is equal to 2 plus or minus the square root of 5. In other words, we have irrational solutions here, and we do actually have two solutions. Remember, we have 2 plus the square root of 5 is one of the solutions, and 2 minus the square root of 5 is the other solution. They're both irrational numbers. Now, we would see those as zeros, as x-intercepts, if we were to graph our function. And the function, if you move the 5 to the same side as the x, would be f of x is equal to the quantity of x minus 2 squared minus 5. And if you use your calculator to graph that, you will find those two solutions, those two x-intercepts, but they will be irrational numbers. Now, what about the equation x squared plus 4x is equal to negative 5? Here we have a linear x term, which means we can't just go ahead and square root both sides, because then we would have the square root of x somewhere, and that doesn't work. So we cannot use the same method we just used twice with this particular case, so we have to think of a new method. In order to do that, let's remember those patterns we talked about when we were talking about factoring. Right here you see a squared plus 2ab is equal to b squared. And remember, we call this the perfect square trinomial. And a perfect square trinomial can be factored, as you can see up here, into the quantity of a plus b squared. We can use that pattern by understanding that if we have a quadratic equation in the general form of ax squared plus bx, which is kind of like the one above that we weren't able to solve, if we add a third term, we can turn that into a perfect square trinomial. Now, the third term cannot just be any number. What we have to add is b half squared, and then we complete our trinomial. b divided by 2 half will complete our trinomial. Let's look at the example above. 6 is in the place of b. If we take 6 and we divide it by 2, we get 3. And if we take 3 and square it, we get 9. This is the perfect square trinomial. And on the right side of our equal sign, we see how we can turn that into factored form. The 3 that we have just found out reappears in a parentheses, x plus 3 squared. So expressed in standard form, that would mean we have an equation, a trinomial of the form of ax squared plus bx plus quantity of b divided by 2 squared. Well, let's look at an example and see how it works. X squared plus 8x plus something. What do we use here to put in as the additional number? Take 8 and divide it by 2. We get 4. 4 squared is 16. And that is the number that goes here. And since 4 was the number that we squared, that tells us that in factored form, we got the quantity of x plus 4 squared. And that's all we do here. Let's look at the other example. Sometimes the numbers can be divided evenly by 2. Then we're going to be left with a fraction, but that's okay. Negative 7 divided by 2 will just be negative 7 halves. Now we have to take the square of that. If we take the square of a fraction, we square both the numerator and the denominator. In other words, 7 squared is 49, and 2 squared is 4, and this is our trinomial. And let's talk about all the steps that we have to perform in order to solve a quadratic equation by completing the square. The first thing we need to do is we need to isolate the constants on the right. In terms of our example here, x squared minus 8x plus 4 is equal to 25. We need to subtract the 4, and we get x squared minus 8x is equal to 21. Now we're going to add the quantity of b divided by 2 squared to both sides to complete the trinomial. What is half of 8, or half of negative 8 to be precise, is negative 4. Square that, we get positive 16. So we are going to add 16 to both sides. In our next step, we're going to factor the left side and simplify the right side of our equation. We had negative 4, which was half of negative 8, squared turned into 16. So our factored form is x minus 4 squared. And on the right, we have 21 plus 16, which is 37. And in our last step, we're now solving the equation by taking the square roots of both sides. quantity of x minus 4 squared is equal to 37. Let's take the square root of both sides. On the left, nothing really has to be done. The two operations cancel each other out. On the right, we now have plus or minus the square root of 37. Add 4 to both sides. And x is equal to 4 plus or minus the square root of 37. The square root of 37 cannot be simplified any further since it's a prime number. 4 plus the square root of 37 is one of the solutions, or minus 37 is the other solution. We have two solutions, remember, and both solutions are irrational numbers. Alright, these are the steps of how to perform the method completing the squares. So now go ahead and watch the second part of this tutorial where we're going to deal with some examples.